Hello, welcome back. Today we're going to be taking a look at the 2014 AP Calculus exam, particularly the free response questions. Now in 2014 there were two questions on the free response that were graphing calculator, and we're going to use the CAS, the TI Inspire CAS for this video. If you don't have a CAS, that's okay, a lot of calculators will work with this. And if they say you can use a calculator, use a calculator. So let's go ahead and get started. For question number 1, they're telling us grass clippings are placed in a bin, where they decompose for t equals 0 to 30. I'm assuming that's probably in days right there. The amount of grass clippings in the bin is modeled by this value right here. So I'm going to go ahead and underline this because it's an important equation right there. So this is a value. It's telling me the amount of grass clippings. So that's a value. Not a derivative, but it's the function itself. Where A of t is in pounds and t is in days. So this equation right here will give us how many pounds of grass clippings we have over t days for the first 30 days. Our first question says, find the average rate of change of A of t over those 30 days. And notice here it does say indicate units of measure. So average rate of change. Well, this shouldn't be too hard for us. It kind of spells it out for us, average rate of change. This is our AROC question right here. And so to answer this question, we're just going to use our average rate of change formula. So we should remember, if you need to, what AROC is. Average rate of change is just your slope formula, f of b minus f of a over b minus a. So for us, we're going to use a of 30 minus a of 0 over 30 minus 0. Now this is a calculator question again, so they don't expect you to do this in your head. But you do want to write out your formula right here. But the rest can be done on calculator. Oops, let me go to graph here, calculate here. And I can type this in. 6.687 times 0.931 to the 30th minus 6.687 times 0.931 to the 0 power. And I could just type that in my calculator. Kind of hard to see there. And if I type that in my calculator here, it's kind of hard to, hit enter, press enter, and I get this on top, negative 5.90407. Now I'm going to go out all those decimal places. Negative 5.90407 over 30, and if I divide that by 30, of course, let's see what we get here. We get this negative 0.19, and let's see, it only goes about 3 decimal places, so we're going to round that to a 7 right there, although the AP would have accepted the 6 in this case. And so we got to get the units right now. Now the units are the tricky part. So if I take a look, well, the top is my change in pounds. So the top is units in pounds. Can't spell pounds, right? Ooh, let me do that. This just looks terrible. Pounds. And the bottom is in days. So this would be, in our units, pounds per day. Now on the AP, this question isn't worth much. It's only worth 1 point on the AP, but it really shouldn't take you that long to answer this question right there. But again, it's pretty easy. So just make sure you're typing it in the calculator correctly. Although you could have even left your answer this way, just do pounds per day as well. All right, so let's take a look at part B. Now part B, where we're getting into the actual calculus of the problem. And here they're saying, find the value of a prime of 15. So notice for this one, they're looking for a derivative. Now again, this is a calculator question, so the AP does not expect you to actually take the derivative of this equation right here. You can use your calculator. So to get, whoops, let me do black ink here. So to get a prime of 15, I'm just going to use my calculator. Ready? So I can go to Menu, 4. This is the Inspire. Now, if you have the Inspire CX, you're not going to have this derivative thing right there, okay? But you will have derivative at a point, so you can just type in B right here. Enter. Looking for the value, I'll just keep it as X. I'm looking for the value at 15. Looking for the first derivative, press Enter, and I can just type in the equation, 6.687 times 0.931 caret X. Now they use T, but I'm going to use X, and that's okay to do. Press Enter, excuse me, and we get this negative 0.164. Now again, I'm going to go negative 1.164. The AP would have accepted a 1.63. So this becomes negative 0.164. Now again, we're not done yet, because then they say using the correct units, interpret the meaning in the context of the problem. Well, if A of t is pounds, and then the derivative would be pounds per day, and because it's negative, we are losing. So a good way to write this, we could say the amount of grass clippings what you can say is decreasing at a rate of 0.164, keep your units here, pounds per day at t equals 15 days. So let's think about what we have here. We got the answer. Now the AP, ready, will give you 1 point for your answer, and over here, and they're going to give you 1 point for your reasoning. But notice in the reasoning, what am I including? What's changing, how it's changing, and by what it's changing, and when it's changing. So you got to have a lot of information when you write these answers. Anytime they say interpret the meaning, it's a lot of writing for us, almost like a stats course, almost, right? All right. So again, now already we're at 3 points. Now remember, AP questions are normally only about 9 points, and we're about halfway through the problem. So that's pretty good. We got 3 points. So now we're going to bulk up on points right here. And remember, if you can average like 4 or 5 points on the AP exam, you're looking at a solid 4 on the AP test. All right. So let's see here. Find the time for which the grass clippings in the bin, now this is a little bit tough one, is equal to the average amount of grass in the bins over the 30 days. So now this is a little bit tougher to do. We want to find the time t for which the amount of grass clippings, that's A of t, is equal to the average amount of grass clippings. Well, remember, this is the average amount, that's our fave. That's our average value right there. So this is a little tougher question right here. So let's see if we can go ahead and write this out. So I'm going to go ahead and write this out. My formula, I already got my formula. A of t is equal to my average amount. A of t I know is this function, 6.6. What is it again? 6.687 times 0.931 to the x. I'm using x here because my calculator is going to have x. But if you're like, oh no, I got to use t, that's okay too. AP is okay, just use a different variable. Is equal to the average value. Remember my average value. Remember this 1 over b minus a from a to b, f of x dx. So this is going to become 1 over 30 minus 0 from 0 to 30 of a of t dt. All right. Now, so I'm just going to go and type this in my calculator again. So now I'm going to use my integral here. Ready? Menu. Use my calculus again. Integral from 0 to 30. A of t, 6.687 times 0.931 caret x, even though they use t, I'm using x. I could use t here if I want to, but I like to use x. Press enter, and I get this 82.5791. But remember, I have to divide that by 30 still. So I divide that by 30, and we get 2.75264. Now notice I go out pretty far right now, okay? and this is going to equal my A of t. Oops, my 6.687 times 0.931 to the t. Alright, so let's see here. So I'm not done yet. See, now I got to find out where these meet at. And how do I find where they meet? Well, I am just going to type that in my calculator. I'm going to use my graphing capabilities of my calculator here. Now, some people like to use the solver. I'm not a big fan of the solver. I like to graph it. Okay? So the first thing I'm going to do is I'm going to graph my function. 6.687 times 0.931 caret x. Enter. There it is. And then I'm going to graph this 2.75264. And I'm going to look for where they meet at. I got to go a little bit further here, so I might change my menu. Entry. Window. Window settings. So I might change my X max to, let's say, 20, just to see if they do meet somewhere here. Yep, they do meet. All this label's in the way, so I'm just going to get rid of those. Let's see here. Come on. Well, let me do it. There it is. There it is. And I'm going to find out where they meet. Menu. Whoops. Analyze graph. Intersection. Here we go. From here to where they meet. And it looks like they meet at 12.4. But remember, they want to go out pretty far. So if I just highlight over that, I press enter. I think if I press enter, it goes a little bit. That's that. Oh well. All right. So anyway, so there. Enter. All right. Not working for me this time. But anyways, it should go a little bit further. But what we get is about 12 days. So we should, and it actually answer is about 12.415 days is where they will meet. I might have to change my settings on mine. So how do they grade this? Now this is only a 2-point question right now. You're going to get 1 point for just getting the answer here, right here, and you get 1 point for your correct answer. So already we are up to 5 points on the AP. And then we get to part D. So 5 points on the AP is really good. That's like a 4 on the AP right there. Now it says for t is greater than 30, L of t, the linear approximation to A, there's a key word there, linear approximation at t equals 30, is a better model for the amount of grass clips remaining in the bin. Use L of t to predict when there will be half a pound of grass clips remaining. So it talks about linear approximation that basically says tangent line. So we're going to look for a tangent line here. So to get a tangent line, we have to know our known value. We're ending up at 3, so I need to find the value at 30, and I need the slope at 30. And I can calculate those on my calculator again. All right, so I'm going to use my graph. Since my graph is already, since it's already graphed here, if I go to menu from my graph, analyze graph, I want to find the slope. Pretty easy, dy dx. Choose which graph. Graph 1. I'm going to type in 30. If I press enter, it's going to give me a slope way down here. It's kind of hard to see, but it's negative 0.056. So the slope is negative 0.056. I can also get the value at 30. This is a lot of stuff right here. I can also get the value at 30. So let me go ahead and clear this derivative out. And this point out. I don't need that point anymore. There we go. So let's go in menu. To get the value, go trace, graph trace, type in 30, and it gives me 0.783. So there's my value, my point, 0.783. So my tangent line would be y minus 0.783 equals my slope, negative 0.056, And that's going to be, they use t, so I'll use t. You can use x. I'll use x even. X minus, and my x value there is at 30 days. So there's my tangent line. And now I want to find out when it'll be 0.5, so we're going to let y equal 0.5. That's my y value right there. So we go 0.5 minus 0.783 equals negative 0.056 times x minus 30. And you solve this, and what you wind up with is 35.054 days. You can solve that by hand real quick. That's not too bad. So how do they point this out? Okay? Well, if you got your tangent line, that was worth 2 points. Even just your tangent line, you got 2 points. Now think about this. This wasn't that hard of a question. One here, pretty easy. 2 points right there. There's 3 points. Another 2 points, not really all that hard right there. And now we've got 2 more points. So you got 7 out of 9 points. Plugging in the 0.5, they gave you plus 1 point for that. Look at that. That's 8 out of 9 points. Just plugging it in, you got a point there. And then you got 1 point for your 35 right there. All right. So that's question number 1 from the 2014. Go on to video number 2. We'll take a look at question number 2. I'll see you then.